Now that you have a 500-foot view of how RxJava works with both simple and complex scenarios, let's dive into the first component and explore observables. This video is broken down into 6 parts. Well, first, we'll take a look at an overview of all these different types, and then we'll move on to the 5 different types that RxJava provides, starting with the simplest and moving on to the most complex. You'll find that all of these are just repeating patterns of basic building blocks, so you'll see how the arc works from the simple types all the way up to the most complex and powerful type. Let's take a look at the 5 different types of observables that the RxJava framework provides. There are completables, singles, maybes, observables, and flowables. Now, each one of these things are classes with a unique purpose, which we'll explore as we go through them. You'll also start to see many similarities unfold as we go through these as well. Now, there's one thing I wanted to clarify before we move forward. Since the last video, I've been talking about observables as a type or as a concept, but as you can see in this list, we had an observable class. So what's the difference between the concept and the class? Well, the observable class is the most all-purpose implementation of the concept, as we'll see later on. That's why it has the most generic and non-descriptive name on this list, because it's the overall best idea that kind of captures what the concept is in code. Others that we listed, such as a flowable or a completable, have a more specific implementation of this concept, and that's why they have a more purposeful name. So I didn't want you to confuse the concept of observables, which refers to all of these classes, with the observable class itself, which implements the best and the most generic approach to this concept using real code. So now that we have an overview of the 5 different types of observables, let's dive into the first one, where we look at completables. Completables are the simplest of all observable types, and it's capable of telling you 2 different things: success or error with some sort of exception inside of it. Now, the success case has no information. It's simply an acknowledgement that something succeeded. Now, when might this be useful? Imagine that you have an application where the user can update his or her profile. When they do that, the app will probably make a call to the server, which will update it in a database and then give you an acknowledgement when it's done. So whenever it's completed, it'll probably give you something like a 204 in the success case. Well, a 204 simply indicates it's successful, but there's no content. So in your code, you probably don't want the exact 204 code that you got back from the server, but you want to mirror the intent of that with a completable, basically the success or the error outcome. The errors always contain either an exception if you're using Java or a throwable if you're using Kotlin. Now, this applies to every single observable type whenever they error, not just completables. So whenever a completable either completes or when it errors, it's what's called a terminating condition, meaning you won't have a completable call the complete condition or the error condition more than once. Now that we have completables under our belt, let's add on to this a little bit with a single type. This builds on the previous concept. Singles also tell you 2 different things: success or error. But the thing that sets it apart from a completable is that a single will always tell you a single piece of data on success. Now, this data is always guaranteed to be not null and will always be present. But it's like a completable in every other fashion. It has an error condition. It will only call the success condition one time. It will only ever have one piece of data, and calling either success or error is a terminating condition. Now, I use singles all the time in my applications, and here's a great example of whenever I use it. If I need to make a call to a server and get a response, the success condition could contain a class that models the response that I receive from the server, and the error, of course, would be when anything else goes wrong. Overall, it's pretty simple. So that wraps up completables and singles. Now let's move on to a maybe. So just like this concept, a maybe builds on top of the previous concept. In this case, we can have 3 possible outcomes: success, empty, or error. Now you might be wondering, why does RxJava have a completely separate type just to model an empty condition? Well, as I mentioned before, singles always guarantee that you're going to get a non-null response, meaning you're always going to get data by the time you land in the success case. So if I don't have data to generate, I simply can't send null and have it land in the success case. So the question is, how do I model empty data? Maybe I can come up with a really fancy way of trying to do it on a case-by-case basis, or maybe I could throw an error when I don't have data to generate, but that just doesn't feel quite right. So that's why the team at RxJava, they created a specific type on top of a single, which allows you to have an empty condition. The success condition and the error conditions work just like they do in a single. And in this case, the success, the empty, and the error conditions, these are all terminating conditions. Here's an example of whenever I use maybes in a real-world application. In my application, I have a local database installed on my client, and I have a class that I use to access that information. So in the case whenever I'm looking up a particular record, I have the success case indicate that the record was found, the empty case indicate that the record was missing, and then of course error indicates some sort of error happened. So that takes care of the first 3 types. Let's move on to observables, where things start to get... With observables, things start to look a little bit different. Now, it's not harder, it's just more powerful. So up until now, we've only been able to report on outcome. We couldn't report on, say, 2 or 3 or anything like that. But that all changes with this type. With observables, 3 possible outcomes: next, complete, and error. Now, we already know what the error is. Let's take a look at next. Next allows you to report out on one piece of data, much like a single, but you can do this multiple times. So we would say technically that next is non-terminating. So let's say if you have 15 pieces of data that you need to report and you can't do it all at one time, this would be a great option. For anybody who's listening further downstream, they can keep receiving data from your observable until the complete condition is called. Now let's take a look at that complete condition. The complete condition is just like a complete on a completable. It doesn't have any data. It just is simply an acknowledgement that things have wrapped up. This is also a terminating condition, meaning you can't send data using the next function anymore after you've called complete. A great use case for observables is inside of a chat application. So imagine that you're inside of a group and you're connected to a server via a WebSocket. Anytime you get a new message from the group, you could use an observable to deliver that update to the UI via an invocation to the next function. And whenever the chat ends and either you or the server wants to hang up, you can simply call the complete condition, meaning that no more messages will be delivered and the client-server connection is done. Now that we have observables under our belt, let's move on to the last type, which is a flowable. Now, flowables, for all intents and purposes, are very similar to observables. They have outcomes. Next, complete, and error, and they all behave the exact same way. But flowables have an extension which allows you to add what's called back pressure. Now, back pressure is a way for you to limit how much data you will consume in the next handler. So let's imagine that you have a producer which is generating too much data for your consumer. You can give RxJava several strategies for how to throttle or dismiss the overwhelming output. A great example of when you might want to use a flowable is, let's say you have an application with a search bar inside of it. So whenever the user starts typing in the search bar, you might want to have a type ahead feature with suggestions, sort of like what Google has in their search engine. Let's say this feature requires a server call in order to generate those suggestions, and it may not make sense for every single keystroke to trigger a call to the server, especially if this user is a fast typer. So in this case, the calls to the server would be expensive and very slow, and fast typers typically only care about the very latest suggestions. In this case, your producer would be the search box, which produces updates on every keystroke, and the consumer would be something like a networking service that takes the current text from the search box, makes a call, and then provides a suggestion. In this case, the producer is very fast, and the consumer is most likely very slow. So flowables are the perfect solution for this. Just like observables, the complete and the error conditions are terminating, while the next condition is not. The next can be called as many times as needed until the terminating condition is reached. By now, we have a great theoretical understanding of how the foundations of RxJava works, particularly around observables. But if you're like me, you're probably itching to start writing some code. But we're going to do that in the next video, where we start putting completables, singles, and maybes into action with real-life code. I'll see you there.